Okay, so today we're looking at stem and leaf. So a stem and leaf we'll see mainly when you'll see a back-to-back stem and leaf plot, and it's good when you have two sets of categories with the same numerical data. So what that means is, so we're often going to see, so you might have, say, the heights of all the staff members here, and you might have females on this side and males on the other side. So say we were doing that and we have a stem and leaf, we might have the stem is the starting number of the thing, so then say 14, and then if I put a 5 there or an 8 there, that means those two females, one's 145 centimetres and one's 148. So you'll have a key, which is crucial. So we would have a key to say that equals 145 centimetres or whatever, all right? So back to back is you'll see that a lot in your exams and your SACs. And male and female is a common one. Maybe if I could do it for 2 class sets, so I've got 2 further classes, I might do the results of the SACs back to back. Okay, so the advantage of an ordered stem and leaf plot is that the values are positioned in such a way that you can see the shape, if there's outliers, and also the spread. So if you have a look here, here's the stem and leaf. So down here they've told me the key. If I have a 2 in the stem, that means a 20, and the 2 is the leaf, is the unit, so it means 22. So you see here, if I was popping this list into my calculator, I would have a 16, I'd have a 22, have another 22, I'd have a 23, a 30, and so on. So if you have to get some statistics on your list, that's how you can read your list and pop it in. Now, so if you notice, the leaves have to be smallest to largest. You have to have them in order, because then that way you can measure and read off the shape. So if I grabbed this stem and leaf plot and show you, if I just turn it like that, can you see how it looks like a histogram? And you can see what the shape is. So the shape would be, for this one, would be symmetric, okay? So just be careful when you do flip it that you're going small, the numbers are going smallest to largest, and I'll show you why in a minute. All right, so here's some examples of what you can use, males and females, I said that, maybe ages in 2 football teams or scores in 2 classes or whatever. All right, so here is a stem and leaf. So we said again, you can, if you grab this and you turn it on the side, we'll see. So this says there's 23 students here in this stem and leaf plot. So what that means is there's 23 leaves. So that's how you know how many students there are. So you can count the 23 like that. So if you're commenting on the shape, you sort of flip it around like this, and we could say this one is symmetric, and that's where they've noted that there. Now, they find the centre, so when they're talking about the centre here, you want to find the median. So you could enter the list in and do the stat calculations, or you can quickly find the median by finding it at the n+1 divided by 2 position. So remember how we did that? So they said 23. So if I did 23 plus 1 divided by 2, that'll be the 12th. So if I go through them, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 30 is the median. So can you see they will say that here in the distribution is centered at 30. They just say the median. You can say the median is at 30 and you're commenting on the center. With the spread, the spread is just the range. So the spread so it's the range. So you get the maximum and minus the minimum. So this is where they got 60 minus 15, they said the spread, and there was a possible outlier at 60. So we should probably say, when we comment on the shape, we probably should say it's symmetric with a possible outlier. Okay, and then you'll be covered there. So they often say if they ask you to comment on a graph, that's what we're looking for these points, the shape, the center, the spread, and so on. You can write dot point. I will mark you correct. I don't need a big long sentence, yeah? Just say the shape of it, symmetric, whatever. Okay, so I just want to show you, this is a back-to-back stem and leaf plot. What I want you to be careful with is when you're describing the shape of this side of a stem and leaf, because what you often get used to, oh sorry, I didn't cut that whole thing out, I didn't get the stem. When you flip this one around, be careful, see how down here, that's the highest number, isn't it? Not the lowest. So really, when you're on this side, it's the reverse. So say this one, it has a lot of the data maybe at the start and then tails out. So this one is positive skewed. So what I think we might want to do, and we can just put it in this space, is I'm going to draw up just a little rough examples of stem and leaves with the shapes so that you might, so you can have an example. So if I did a stem and leaf, I'm going to show you both sides if they were positive skewed. Okay, they would look like this. They'd both have a lot of data at the start. So it's banked up in the early numbers and then it tails off. Okay, so that is a positive skewed scenario for either side. If you have negative skewed, so if we have negative skewed, we'll draw what that looks like. So we'd have, what we're going to see is probably it then bangs up after at the later part in the big numbers. All right, so you'll see that's what happens if it's negative skewed on either side. So just be careful. You might want to pop it in, even draw these near your histogram diagrams of positive and negative skewed so that you know. Okay, so let's do this question. It says the developers record the noise level at two proposed residential sites, A and B. The results are listed in a back-to-back stem and leaf plot. Which of the following statements is true? So the median level at A is 52 and the median noise level at B is 53. So let's practice finding the median without typing the whole list into our calculator. So first of all, let's find out how many numbers there are in each site. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So N is 16 for this guy. And if I do the other side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So they both had 16. So if we were going to find the median, we'll find it at N plus 1 divided by 2 position or spot. So we've had 16 plus 1 divided by 2. So in the 8.5. All right, so if you count them up, so go 1, 2, 3, 4, 5, 6, 7, 8. So the 8.5 will happen for this one between 50 and 53. What's the number in between there? 51.5? Yeah? So the median level was not at 52, was it? No. And then they want which statement is true. So if I go through this one, the 8.5, 1, 2, 3, 4, 5, 6, 7, 8. So it's in between 52 and 54. What would the median be there? 53. So which one of the statements true? I'm going to say that's true. And I'm going to move on. in my exam because I've got an answer. What I will do if I get checking time, I'll check these, that these are wrong. Yes, because we want to do something different. We don't want to make the same mistake. Yeah. Let's do this other example. So make sure you read the key. Be careful because it can be a decimal place, not just a whole number. But they're saying 1-9 is 19. So I've worked that out. So the stem and leaf plot above shows the ages of people in the Tai Chi class. What is the median age? So first, you can type all the lists in, but see, that would take a long time. If you went into lists and spreadsheets and you could type like 19, 21, 23 and so on, and you could get all the data and then go and press menu stats calculations and get the median that way. Only do that if you're getting asked like more than one question on this. If not, we're probably going to find it the manual way, like what we've been practicing. So we'll count up how many people we have. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I know n is 20. So my median can be found at n plus 1 divided by 2. So 20 plus 1 divided by 2, so 10.5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and there's 11. So it's somewhere between here. So the number between 33 and 34 would be 33.5. So there's your answer. Another thing you could do, you've done it manually. If you've got time at the end of the exam, you could go chuck it in your calc, yeah, and check it that way. That would be a different way that you've found it. This question, a company that sells jeans of 20 different, has 20 different outlets. The results of sales at jeans at each of the outlets on a particular day is listed. So there they were nice. They gave us to the N, so we don't have to count it if we need it. What percentage of the outlets sold more? So remember, I want you to start circling when they say what percentage. As soon as you see that, I want you to write amount out of total times 100. Okay, what percentage of the outlets sold more than 50 pairs of jeans? So there's a total of 20 outlets and we want more than 50. So you go here, this is 50. So they're saying more than 50. So I'm going to say 51, 1, 2, 3, 4, 5. There were 5. And then you times that by 100. So that's a quarter. So what would that be? 25%. Done. All right. The stem plot in figure 1 shows the distribution of average age in years at which women first marry in 17 countries. So I got told N was 17. So be careful here. Here's where they're saying the leaf is a decimal place. So this, say for example, this number here is actually 26.6 years. Okay, so be really careful. For these countries, determine the lowest average age of women first married. So what would that one be? 25, yeah, that's the lowest number. And then the median average age for women at first marriage. So we can find n plus 1 divided by 2. So it was 17 plus 1 divided by 2. So it's the 9th spot. So if I go and count 1, 2, 3, 4, 5, 6, 7, 8, 9. So it was 28.2. Okay. Okay, the back-to-back stem and leaf plot shows the number of newspapers purchased each month by a sample of men and women. So they've given the key, so it's just a whole number. Now, careful here. What percentage of women? So of women, so the percentage, remember, is amount out of the total times 100. They just told you the total there of women. So you've got to count the women up. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I actually know this total was 10. Now, of those women, how many purchased at least 24 newspapers? So I go to 24 and at least 24. So that'd be 1, 2, 3. And then you times it by 100. So that'd be 30%, yeah? Done. Okay, so with a dot plot, it's only used for discrete numerical data. So discrete means it'll just be a whole number, really. Yeah? So you count it. So you won't see measurements, you won't see like heights or that because we can be in between. It'll be a discrete. And a dot plot's for small amounts. The dot plots are silly if there's millions of numbers, so it's not really worth it. Just be careful, if you're asked to construct a dot plot, you must have a ruled number line underneath. So if I was doing this one, got to rule the number line and then just break it up. So you just have your equal intervals like that. So you can copy off the calculator, but just make sure like down here and that you just put the dots. So say this was 21, you've got one of them, so you're there. So when you've got 22, see there's 2 of them, so you'd have 2 dots. And it's very similar in terms of you can comment on the shape. So if we had a look down at this one, I might say this one is positive skewed. There's more data at the front, and this one I might say positive skewed with possible outliers, because this could be outliers. So with possible, I get away with saying, possible. If I don't know, I've just said they look like it. Not sure yet, haven't tested. All right. Okay, so the dot plot below displays the difference in travel time between morning peak and evening peak, travel times for the same journey on 25 days. So they did, they've written it there anyway. 25 is my N. The median difference in travel time is, so we've got to get the median. So just remember, median is found at n plus 1 divided by 2, so it'll be 25 plus 1 divided by 2, so it's going to be the 13th spot. So the way I'm going to count is like this, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So this one was on 0, 1, 2, 3, was on 3, so 3 minutes. So water skink eggs are hatching in the reptile house at the Millville Animal Sanctuary. The number of eggs hatching each day over a 31 period is recorded. So right there, they told you N is 31. They've put the results for the 31 days. Write down the range. So remember, the range is max minus the minimum. So we go and look, the smallest value is here at 15, and the largest one is 23. So we're going to say 23 minus 15, which equals 8. Okay? What's the median? So remember the median, once again, n plus 1 divided by 2, so it'd be 32 divided by 2, so the 16th spot. So I'll count up them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I'm in 19 eggs. And now it says, write down the number of days which exactly 21 eggs were hatched. So if we look for 21, how many were in 21? None. So 0. And once again, be careful, they're asking the percentage of days. So I'm going to say percentage is amount over total times 100, percentage of days. So there was a total of 31 days, which had more than 19 eggs. So more than 19. So 19's here. So more than. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 over 31 times 100. And just we're taking note, it's 1 decimal place. So what does that equal? 38.7%. Okay, beautiful.